Ladies and gentlemen, good day. I am Jessica Canindin from Group 4 and I am going to discuss about multi-drug resistant bacteria. So first, let us define what is multi-drug resistant bacteria. So they are bacterium that are resistant to one or more antibiotic. So these bacterium have a several different resistance to a particular antibiotic. That means that uh, those bacteria are not easily eliminated by a specific antibiotic. So, since they are resistant to a particular antibiotic, they are not easily eliminated, or they can easily die to one antibiotic. So, they need uh, much stronger antibiotic to be able to eliminate. The accumulation of resistance genes takes place on the small DNA pieces called the plasmid. So the possibilities of a single resistant bacteria to become a multi-drug resistant bacteria is through the process of what do we call cross resistance. So what is cross resistance? Cross resistance is the process wherein a single resistant bacteria can become a multi-drug resistant bacteria, wherein uh, bacteria will going to pump out the antibiotic out of the cell, wherein or which can lead to the antibiotic to become ineffective for the cell. It's because the cell cannot absorb the antibiotic. So since it pumps out by the antibiotic by the bacteria, it became ineffective already. So examples of places that are multi-drug resistant bacteria are present, such as hospitals and animal farm, wherein these places are suitable for multi-drug resistant bacteria to be able to spread, and this kind of environment are suitable for them to be able to reproduce. Example of multi-drug resistant bacteria is the ESBL, or as extended spectrum beta lactamase, wherein gram-negative bacteria such as E. coli and Klebsiella pneumoniae are produced. These ESBLs extended spectrum beta lactamase are enzymes that destroy most of important antibiotics. So which leads to those infections with which is ESBL is present are hard to treat. Something to worry more about is that those people who are ESBL carriers are asymptomatic. So more than 50% of the community on some part of Southeast Asia are colonizing by ESBL, and that is according to the recent estimate. Sad to note that the number of ESBL are increasing to other part of the globe. So it may lead to a risk in the future antibiotic resistant infection. So in addition, I just want to share a experience of mine before, wherein my father asked me to buy an antibiotic on the pharmacy. So I go to the pharmacy and ask for antibiotic, but the pharmacist doesn't give me, or he or she didn't even give me an antibiotic without the prescription of doctor, since it may be because of this kind of issue, wherein it is very beneficial to me, not only to me but also to other people around me, because I can apply it not only for my family, and but also I can share it to others, this kind of experience.
Hi, good morning. I am Andrea Dulay. I am biology student. Today, I will explain to you the multi-drug resistance in bacteria. Multiple drug resistance in bacteria may be generated by one of two mechanisms. First, this bacteria may appropriate multiple genes, each coding for resistance to a single drug within a single cell. This accommodation occurs typically on resistance or plasmids. Chemical mechanism or resistance. It is the first necessary for us to review verified commonly encountered mechanisms of resistance.
Good day everyone, I'm Jonaline Rivera from Group 4 and I am going to discuss about the development of multi-drugs resistance microbes. So, how a bacteria becomes multi-drug resistant? So, bacteria create a defense strategies called resistant mechanism and do so by using its instruction provided by their own DNA. Bacterium can sometimes share their DNA and make other germs resistant. Example of defense strategies is including bacteria, restricting the access of multiple antibiotics. Most bacteria gets rid of the antibiotic by using pumps in their cell wall to remove antibiotic drug that enters the cell. Bacteria can also destroy the antibiotic by using its enzymes to break down the drugs. Most antibiotics are designed to single out and destroy bacteria. However, they can change the antibiotic's target and will no longer fit and attach to the cell wall. For example, E. coli. Bacteria with the MCR1 gene can add a compound to the outside of a cell wall so that the drug cannot latch onto it. Although drugs that fight bacteria eliminate them, as we use more of the drugs, bacteria finds and develop ways to survive, making them resistant to multiple drugs. What causes multi-drug resistance? So, drug resistance can happen through the repetition use of the same drug. Most common one is antibiotic. Although some bacteria will be eliminated, most certainly a group will survive and may develop a stronger resistance to antibiotic. When a bacteria becomes resistant, the antibiotic can no longer affect the bacteria. These bacteria can grow and spread and can cause diseases that are harder to treatment because of their resistance. Bacteria can even spread the resistance to other types of bacteria they met, making them spread rapidly and much more difficult to handle. Many ways to prevent this is learning how antibiotics use and develop for necessary purpose. Treating any bacteria problems is very difficult when antibiotics no longer any effect of the patients to the bacteria multi-drug resistance and strong defense mechanism of the certain bacteria.
These ESBL or extended spectrum um,
Although drugs that fight bacteria emulate
Bacteria may be generated. These bacteria